Using a wave motion demonstration to explore wave properties of speed, frequency, and wavelength. My name is Allison, and I will be your narrator as we progress through the demonstration to describe the motion. Then Beth is working on our left side of the demonstration, and Simon will be working on our right side. Simon has placed a piece of fluorescent tape on his thumb. He will be moving his hand up and down. This is the oscillation source of the wave, and it will move along the yellow spot medium. You see he's gone ahead and has created the wave pulse. The wave pulse is moving at a constant speed, and when the pulse reaches the opposite end, the left side, you're going to see that it is reflected and moves back toward the right side. Next, we're going to wait for that wave to dissipate, and we're going to create another continuous wave moving from right to left. As you're noticing and watching this wave motion, you're looking for the high points, which are going to be your crest or the peaks of the wave, and you're also looking for the low points, which are the troughs or the lowest points on your wave. Now we're going to give Beth a moment to let the simulator dissipate the energy, and she is going to attach an oscillation device to our demonstration tool. She's going to has set this to 1.5 hertz. Hertz are the unit that we use to measure the frequency of the waves. This is going to be a mechanical oscillation. So you will notice as she turns the oscillator on, we are getting the wave. You are also seeing on this wave the crest and the troughs. Simon is flipping up a device that we can measure the wavelength for this particular wave. If you note the fluorescent pieces of tape on the yardstick, you will notice that they correspond to the crest and troughs on the wave. Let's make this kind of a game and see if we can determine what the wavelength will be. So if you take a moment and you count very carefully, you should see 6 vibrations every 4 seconds. This takes in a very astute eye to be able to notice that very quick motion. Now we're going to adjust and look at what would happen if we change the frequency. We're going to decrease that frequency to 0.75. Let's watch how that affects the different wave properties. So Beth has started the low frequency oscillation. You will notice that there are less vibrations moving down our demonstration device. Therefore, you can also notice that the crest and troughs are going to be in different positions. Let's also take a moment and let's see if we can count the oscillations for this particular simulation. You should notice that the oscillations have changed to 3 times every 4 seconds. Finally, we're going to let Beth press the button to stop our actuator, and we're going to disconnect that. So in reviewing, when we saw our high frequency oscillation, we should have noticed a shorter wavelength. When we saw our low frequency oscillation, we should have seen a longer wavelength. And note that we are also had vocabulary such as crests, the high point on the waves, and troughs, the low point on the waves. This concludes our demonstration.